So lock your hands like this, right? Inhale, and when you are exhaling, then pull it in opposite direction, right? So inhale and pull it when you are exhaling, not when you are inhaling. Let's do it 5 times. How did it feel? Nothing? If you start doing it regularly, and before you go to your difficult meeting with your advisor, and do this before you go, you will be a lot calmer and you will have a clarity of thought. Anyway, have a seat. I'm sure this is the part you all will remember for the longest. Right, so how many of you have heard about Sustainable Development Goals? The United Nations Sustainable Development Goals, SDGs. Okay, some of you, what are they? Water and sanitation for all is one of those, yeah. Zero hunger is another one, yeah. Empowering women, yeah. And so many countries have adopted that as a framework for development. And what in next few minutes I will talk about is how some of the tools and skill sets that we have been talking about here can be utilized to evaluate sustainable development goals, at least some of those sustainable development goals. And so at the end of this lecture, I expect you to understand the concept of sustainable development goals as put forward by United Nations, to discuss the solutions and strategies to maintain sustainability for these goals 2, 6, 13, and 15, using some of the case studies that I will talk about. And you should be able to discuss the key sustainability challenges that are related to water scarcity, climate change, and land use changes. So these are 17 goals, right? And if you have not seen it, take a few minutes when you go back today or tomorrow or this week to familiarize yourself. This is something good to know. India is investing a lot in making these a reality, and so are many other countries. No poverty. These are big goals. Zero hunger, good health and well-being, quality education, gender equality, clear water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace and justice, strong institutions and partnerships for the goals, right? These are all really laudable goals, and these are all created to bring prosperity, quality of life, peace and harmony within a country, among the countries. And if you go to the website, it has detailed reports about each one of those. What does it mean? So these promote a holistic approach to development and emphasize the interconnectedness among the global challenges. Water and sanitation is tightly linked with the health and well-being, which is tightly linked with zero hunger. Crucial for promoting global development and ensuring a sustainable future for everyone. These sustainable development goals aim to create inclusive societies, right? Gender equality is one of those. And reducing inequalities for all is second one. So it is meant to be very inclusive. When you talk about zero hunger, so that includes everyone. They also serve as a catalyst for innovation, driving technological advancements in various sectors. And they play a vital role in promoting peace, stability, and prosperity for a just and equitable world for all. These serve as a constant reminder to what we all should be working at. And I frequently go to the website and I look at it. I look at some of the reports that come out regularly. I read papers that relate to these sustainable development goals. So when you look at that and you look at in the context of ecohydrology, right, what can you contribute? What can you work on? There are specific goals. Goal 2, zero hunger, that aims to end hunger and achieve food security. We have been talking about food production, right? We have been talking about ecosystem services and food provisioning as one of those ecosystem services. We have been talking about modeling and how you can use the modeling models and tools to evaluate how much agricultural production takes place in a watershed. Clean water and sanitation, that seeks to ensure sustainable management of water and sanitation for all. It's a big goal. It's a very difficult goal. If you look at the history of mankind, water is number 2 source of conflict. If you look at the battles and conflicts and wars that are happening within the societies between countries, water is number 2. And it goes as far back as the history of humans. Climate action focuses on urgent measures to combat climate change and its impacts. We have talked a lot about climate change this week. And then life on land and life in water, right? Both promote management. So life on land promotes the management of forests and reducing or eliminating biodiversity loss. Life in water is an important part of food production, as well as providing genetic resources and biodiversity. So some of these goals, the tools that we have been talking about here, and if you continue to work on these tools, you will be in a position to make a difference and contribute to these sustainable development goals. So zero hunger, right? It aims to achieve food security and promote sustainable agriculture and emphasizes the need for comprehensive approaches to ensure access to safe, nutritious, and sufficient food for all. What is happening is you look at any society, whether it's India or US or anyone else for that matter, and malnutrition and obesity coexist in the same society. You see people suffering from too much caloric intake, and you see people suffering from not enough nutrition and calories. And it doesn't matter whether you are a hydrologist or ecologist or engineer or social scientist. It's something that we all should be working on. What can we do to eliminate hunger? Has anyone, well, let me not ask that question. To achieve this goal, it is essential to enhance agricultural productivity and resilience and invest in rural infrastructure. So rural infrastructure investment is important, right? Average land holding size has been reducing globally, and majority of the agriculture is done by women. So what can we do to bring the technological advances to make the job easier? Because they also carry additional responsibilities besides being the primary person who does the agriculture. It promotes sustainable farming practices, right, that protects the environment. Innovative solutions such as agroecology and precision agriculture can improve food systems. What I have found in my own interactions with number of farmers across number of countries is that they are very progressive and they know a lot more than we think they know. I'll give you an example. I was in Colombia, in rural part of Colombia. It was so rural that we had to stay at a farmer's house. Farmer and 2,000 acres of land around the farmer's house. As far as I could see, I could only see his cattle. There was no electricity. And there was one solar panel that provided that powered one light bulb in each of the rooms. And there was a generator that was turned on only when cell phones needed to be charged. So a few minutes every day. And the primary source of news was a radio. I stayed at the farmer's house for 3 days. We were doing some work, talking about how that whole region needed to be developed and what could be done. And there was a language barrier. You know, the farmer and his wife only spoke Spanish. I could speak only English, but we were able to talk through an interpreter. And I asked him, you know, what are the challenges that he has? And what he described to me is what state-of-the-art climate change models are telling us. And this guy had probably no idea about any of the CMIPs and any of the climate models, but he said, sun is getting hotter. The water in the ponds are drying up. Groundwater is going down. I'm worried about my cattle. My cattle, because of the sun is getting higher, is hotter, is producing less milk, and then cattle that are used for meat are growing less healthy. And I was totally loss of words, you know, how beautifully he described what our climate models are telling us what's happening. And so I asked him, so what are you doing? And he said that he is thinking about putting a number of solar or wind-powered pumps at different places along his farm to help his cattle and wildlife, because wildlife also needs water to survive, and they are important to maintain the ecosystem in his 2,000 acres of land. So there was someone with no knowledge of ecohydrology and no knowledge of ecosystem services was thinking about what we are talking here, right? So next time when you talk to a farmer, find out, ask them rather than unloading your knowledge to them. Clean water and sanitation, goal number 6. When you look at child mortality between 0 to 5, water is number 1 cause. And when you look at the stunted growth and why children in many parts of the world do not attain a normal adulthood, the reason may be water. The objective here is to improve water quality, increase water use efficiency, and implement integrated water resource management that we have been talking about, and improve water use efficiency along all sectors, right? So, number one user of freshwater withdrawal globally is agriculture, and that goes to produce food. 20% of world's agriculture is irrigated. So irrigation is absolutely needed, otherwise we won't have food security. And the risk will be too much if it is not irrigated agriculture. So idea is not to take the water away from irrigation that is so vital to production of food. Idea is how can we make it more efficient by looking at improvements in water, improvements in plants, and improvements in technology, and that's where you come into picture. That's where you can make a difference. And how can we implement integrated water resources management at all levels? And then how can we seek to protect and restore water-related ecosystems, right? So take a look at this in depth when you get a chance. The climate action, goal 13. Climate change is happening, it is real. What can we do to not only mitigate it, but what can we do to adapt and build resilience, right? In Connecticut, where I live, a lot of our focus is now gone into building resilience. And what can we do to protect the communities that are vulnerable? The impact of climate change would not be shared equally across all segments of the society. Those who are poor will suffer the most. What can we do to minimize the impact on them? And in Connecticut, we are doing a lot of work along those areas, as well as what can we do to adapt to the climate change that is already happening. So the models we have been talking about, ecohydrological modeling, it plays a vital role in climate action. You saw some case studies that Professor Vamsi presented. Adaptation strategies aim to enhance carbon sequestration, reduce greenhouse gas emissions, and preserve biodiversity. 2 years ago in Connecticut, we produced a lot of specialty crops. We produced a lot of fruits. And there was an early onset of warm weather in February. The apple and peach trees blossomed. And then that followed with the frost, killed all the flowers, and practically eliminated all the apples and all the peach that year. Who was impacted? It was the farmer who was impacted, who was relying on that income to carry the family, through the next year. The wealthy could go and buy apples and peaches that came from other states from a grocery store. And those are the kind of challenges we are going to face more and more in future, right? So you can come and be helpful in developing strategies that can help our stakeholders adapt to climate changes. Life on land aims to protect, restore, and promote sustainable use of terrestrial ecosystems. How do we manage forests sustainably, combat desertification, and halt and reverse land degradation and biodiversity loss by 2030? 2030 is what, only 5 years away? Preserving natural habitats and restoring ecosystems, and enhancing biodiversity, improve carbon storage, and provide vital ecosystem services. Do you all feel like you are getting tools in your toolkit to be able to address some of these things? You may not be expert right now, but at least we are orienting you in the right direction, right? That if you keep going, you will become real experts, and you can really contribute to some of these goals. So on the water scarcity, it represents a critical challenge to sustainability that is intensified by climate change, rapid population growth, and inefficient water management practices, and challenges in food production and economic stability. The climate change, extreme weather events such as hurricanes, floods, seems like it's happening a lot, and it's happening at a lot bigger magnitude than what it used to be. And it certainly it's disrupting the delicate balance of ecosystems, making it difficult for a species to adapt or migrate to suitable habitats. So, what's happening in India? You all should be expert. You all live here, right? You all are familiar with the literature. But you look at any period and you see the warming climate, 1911 to 1961 to 70, and then 2011 to 2020. January, February, warming, right? March, April, May. Significant warming. As a child, I used to remember that, Holi was the first time when you start to feel the warmth. And now it is much sooner than that. June, July, August, September, much warmer. And then October through December is also 1.6 degree warmer than what it was at the beginning of 20th century. And so clearly the climate is warming in India, and what that does, it puts an adverse impact on water, it puts adverse impact on ecosystem, on food production, on health, everything. One of the biggest concerns we have, one of the departments in my college under me is Department of Kinesiology. And among different things that Department of Kinesiology does, one is looking at heat stress and impact of heat stress on humans. We have one of the leading experts in the world who does that research. And when I talk to him, he tells me that one of the biggest concerns he has is how do we ensure safety of agricultural workers who are working in hot climate that could be deadly moving forward, and what policies are needed to ensure their safety. See that with the warming climate. On land use challenges, of course, increasing population, and that is driving the urbanization, is putting a big pressure on land use and land management. And along with that, the soil degradation that is happening in tropics, that is altering the hydrologic response. Surface detention and infiltration are reduced because of land use changes, and that is reducing the groundwater recharge, that is increasing the surface runoff. So what happens during the low flow conditions, the dry season, rivers are running dry. And because it affects the groundwater recharge and soil water content, thus reducing the feedback that goes back to the to atmosphere. And so solutions to zero hunger, approaches such as agroecology, permaculture, where we are prioritizing ecological health while enhancing food security. And agroecology encourages the use of organic farming techniques, crop rotation, and incorporation of native species which are more adapted to the changing climate, right, which can be drought resistant, which might require less input as in water and fertilizer. And then permaculture practices, they focus on designing agricultural landscapes that mimic natural landscapes. And we need collaborative efforts, including government policies and community engagement, that are essential to bring these solutions to scale. On solutions to clean water and sanitation, of course, integrated water resource management and public education and community participation are essential components of IWRM. One of the things that we do when I started when I was at Purdue was in our surrounding watersheds and streams, we will bring the community together and we will do the water quality analysis of rivers and streams in the surrounding areas. So everyone will go out, everyone will be given a protocol and a water bottle to go and sample the water, bring it back, and we had quick tests to analyze the water quality. And it was a community science, citizen science, where we were engaging the citizens to do the science with us. And it was one way to increase the awareness of what is happening in your backyard and what can you tell about the quality of the water. We have published some papers on that. Rebecca Loxton published a paper related to that citizen science that we do. But it was a great way to increase awareness of our actions impact the quality of water in your backyard. I don't know the numbers for India, and I don't know if those numbers exist or not, but in US, everyone lives within 10 miles of a polluted water body. Everyone. And some of those things were very visual. You know, when you go, you step into a stream, collect water sample, bring it back, we analyze it, and we share the results. And so when some of you get into a position where you can do the citizen science, think about it. Think about what you can do. On climate action, this is such a big and complex problem, but we need to think about all three components: mitigation, adaptation, and resilience, right? Mitigation in terms of what can we do to reduce the emissions. And then what can we do to invest in climate resilient infrastructure such as flood defenses and drought resistant agricultural practices. Doing research on what are some of the crops that are tolerant to heat and moisture stress, as well as nutrient stress, and promoting those practices. Education and capacity building, programs that can equip communities with the knowledge and skills that are needed to adapt to changing climate conditions. And adapting international cooperation and sharing best practices can accelerate the implementation of effective climate policies. Life on land, habitat protection, restoration of degraded lands, promotion of, I feel like there is a lot happening in restoration of degraded lands here, right? Is that a correct perception? When I talk to folks, I really get that perception. Promotion of sustainable land use practices that balance human needs with environmental health, and restoring ecosystems such as forests and wetlands. Implementing agroforestry and permaculture can help maintain biodiversity while ensuring food security. And communities that do that are, what you will find, that are the communities that are the healthiest and the happiest and usually the most affluent. So it helps everyone. So where does SWOT model fit into all this? It can play a role, and it is playing a big role in evaluating different practices, in informing the science, in informing the policies. Professor Vamsi presented 17 different scenarios that we had analyzed with respect to bioenergy production and how that impacts energy versus food. And there was a big debate going on at that time, food versus fuel. And we were able to show that, yes, there will be some decrease, but that decrease will necessarily come from areas that should not be under food production to begin with. And if you put those areas under energy production, we can meet both goals. Those are the kind of things that SWOT model can provide to you. It can simulate the impact of agricultural practices on agricultural productivity, soil health, and biodiversity. And it can also be used to simulate how various mitigation and adaptation strategies affect water resources under climate change. We looked at some of the emission scenarios and how that affects bioenergy production. And then it can be used to evaluate the impact of extreme weather, such as floods or droughts, and water availability and crop yields and food production, and can be used to simulate a variety of best management practices, such as contour farming, no-till farming, cover cropping, vegetated filter strips, wetlands, you name it. There are a range of BMPs that can be very effectively simulated in SWOT model. So it gives you a powerful tool to be able to go and look at what may be happening in a watershed, what needs to be happening in a watershed in linkage to sustainable development goals. So, case study, flood challenges in Jakarta, Indonesia. Because of the climate change, because of the population density, it's a huge problem. So much so that Indonesia is going to move its capital from Jakarta to somewhere else. And this move aligns with international framework like Sendai framework and disaster risk reduction, because if they don't do that, then the cost of recovery from flooding will be too much for the country to bear. And this should be the last solution, right? That you develop the area to the extent that now it's hard to go back, and you have completely tilted the balance. Now, case study 2, use of SWOT model to evaluate the effect of agricultural BMPs. Bhavesh, right? Bhavesh, where is Bhavesh? You want to present? Come on over. Don't look at him. Come on over. At least both of us can present it. So come. Folks, a big round of applause for Bhavesh.
So my friends, did this work as a part of my MTech work under Professor Vamsi Krishna. So here we are consider basically three type of structural BMPs, not the non-structural like what Professor Chavez had told. So we are consider this check dams, ponds, and bund, and terraces. Okay, 4 structural BMPs to reduce the sediment retention or sediment flow out from the Suvarnarekha river basin, and we try to put BMPs in each and every individual subcatchments or subwatersheds. The subwatershed size, if you see, it is more or less 50 km². Because if you put any type of structural BMPs in a huge watershed or sub-water set, it will not give satisfactory results. It will be good for the lower order stream, or you can trap the generation of the and transportation of the sediment flow out from the stream. So the basic hypothesis here is, if you go to SWOT model, there is a option under BMPs called pond parameter you can put there. There is no function to put the check dams, but might be SWOT plus have these options now. So there you can put what could be your size of the check dam in terms of length, depth and storage, and what could be the inflow and outflow, everything. So check dam as well as pond are simulated in the same way at the outlet of the any particular stream or any particular subcatchment or subwater sets. But in case of terraces, terrace basically reduce the slope approximately 0, because it is like staircases. But in case of bund, it will just reduce the slope length, not the slope value. So in case of terraces, we give approximately very less value, slope length approximately near to 0. And in case of bund, we reduce the slope length only. So there is a parameter in the SWOT also, you can change the slope length and the slope values. So after that we simulate as well, like from 30-year simulation and 10-year validation, and this is our basin, basically Suvarnarekha basin, which is covering this Jharkhand, Bengal and some part of Odisha. Okay. And it is basically we find out that at the time of field survey there is a lots of erosion due to improper knowledge in the management practices. So this is the basically scenario we are formed. First scenario, we are going to this is as a normal condition. There is no check dam, no bund, no structural practices, nothing. So coming to the second scenario, first scenario we told, which is watershed with only check dams. We put numbers of check dam in the outlet of each and every subbasins, only check dams. Then it's coming to only farm ponds. Then we put bondage and terraces. Then we find out which watersheds are prone to erosion based on the statistical analysis and USLE methods, which already saw it have USLE. You can otherwise you can use GIS data to calculate the USLE soil erosion, annual average soil erosion. So based on that, we find out top 75 subwater set which are more erosion prone and put there the check dam of farm ponds. Then like that 50 and 25. Then compare the results with baseline scenario. The scenario we are making, because if you going for only check dams, it is taking much more money economic point of view. So why not we are combine the conservation practices. In order to put only check dams, we put this bund and terraces, because for bund and terraces the excavation cost only there. So concreting unit required to done. So this is the improvement, basically baseline minus scenario by baseline normal equation. So if you see, these are the reduction of the sediment concentration under various scenarios. Okay. So scenario 4, if you see, 40% reduction is there. Okay. And scenario 4 means watershed with all soil and water conservation practices. Like each and every watershed, we put check dam, farm pond and terrace, everything. But in case of scenario 4, if you see, scenario 7, 34. So 54 is highest if you consider all type of conservation practices, and if you consider only 25% of them in the first order stream, then it will give 34%. Now it is your decision as a decision maker, which one you want to choose, depends on your capital. Like land level capital. So these are the results which are plotted here, and as soil basically working based on this water balance. So balance component of the subbasins are presented for each and under scenario here. So that's we mention here, like 45% reduction can be possible if we put all this check dam or farm pond or terraces in each and every water sets, but it is again your decision which one you want to choose.
That was the last slide.
Okay, sorry.
Okay, thank you. You did a great job without knowing what the slides were going to be like. Well, Bhavesh didn't know that I will call him to make a presentation. His advisor did not know that I will call him to make the presentation. Bhavesh, great job. So, what do you get out of this case study? 44% of the areas have severe erosion in the watershed, right? And that means that nearly half of the watershed is having significant soil losses, and nearly half of the watershed is going to be contributing significantly to not only soil health but also water quality problem. And three simple solutions is what he looked at, and where those need to be put. Right? So when you look at, when you are putting all three solutions in the watershed everywhere, right, how much is the reduction that is happening in the sediment yield? About 47–48%. But even if you don't do that and apply those BMPs to only half of the locations, not at every location, but only half of the locations, you still get a significant reduction right here in scenario 6. And if the resources are not there and you could go and do it only in 1/4 of the locations, still the reduction will be remarkable, 40% reduction. And that will play a huge role in maintaining the soil quality, in maintaining the soil health, improving the water quality, and improving agricultural production, because you are putting the fertile soils at their, keeping the fertile soils at their place. And so that's the power of BMPs. What this does not talk about is how you can optimize it, right? So when resources are limited and when you have only a limited amount of money and you have to pick and choose, how do you optimize it? There are a number of papers and work that has been done to do this spatial optimization, including some of the work that has come from my group, and you can look at it. But even if you don't have computing resources to optimize BMPs, you just do some simple assessment of where are the vulnerable areas and randomly pick 25% of those areas, you can improve the health of your watershed drastically. And that's the take-home message I want you to take back, that these BMPs, these conservation practices, are very powerful tool to improve hydrology, water quality, and enhance the food production. So they meet multiple goals. And this is all done using the SWOT model. So that's where you can bring a model like SWOT or any other watershed scale model that you may be working with, and then link those results to sustainable development goals that we are talking about today. So with that, questions? Yeah.
question is while the scenario 2 and 3, when watershed is